Hello, in this video we will create an MPLS TP pseudowire circuit over 10G. At the main iNMS screen, move the cursor to the top and select the tool set, then circuit. This next screen, select TDM PW or pseudowire hybrid. Click on the upper left to add a hybrid pseudowire. A drop-down box will open. Drag to enlarge the drop box. Here we enter the circuit information and select the A and Z circuit end. The red text indicates required fields. Enter the text or click for a drop-down menu. In the first few fields at the top we select the MPLS type of circuit, and it will be SATOP and a VT 1.5 T1. The next group of choices are voice or data, direction, unidirectional or bidirectional. We pick bidirectional, and we select no in band management. Now we work on A and Z endpoint information. The A endpoint information is entered first. At each end we will be selecting the station, the network element, and the port. In our case, both network elements, or NEs, are located in the same station, the test lab. We will select a virtual T1. This allows mapping to dia zeros. Virtual TEs allow VT15s to be mapped to dia zeros in 09500s. We now move down to the Z end of the circuit. Once again, we will select the station, the network element, and the port. Although it may be a different station, network element for sure, and port, the Z end is close to a mirror image of the A end. You can see that when we pick a T1 port, we select number 2 since number 1 is already used. All the necessary information is entered. We select Add at the bottom of the page at this time. Click on the Hybrid Circuit Maintenance icon to see the defined circuit. Right-click on the new circuit and select Allocate. The TDM and pseudowire or PSN attributes are selected in this screen. We previously defined the A side and Z side of the circuit. We are now working with what is referred to as A prime and Z prime, TDM and PSN. Here we select the 10G PTN card and a logical Ethernet port. Now we move to the Z prime end of the circuit. Again, we select the network element or NE and the 10G card and the Ethernet port 1. The TDM data entry portion is now complete. At this point we select the PSN tab at the top. The PSN tab gets us to the screen where we select the pseudowire label. Click on Get Next Free. iNMS automatically assigned us the number 18 for the label. Click on Quick Search at the bottom to have iNMS search for an available route. Circuits already exist, and iNMS informs us of that. We will accept the iNMS choice over a route that already has another existing circuit. Just click Yes. After iNMS populates the screen, review and click Finish if all is okay. iNMS automatically allocates resources. Click OK when the resource allocation function completes. Now implement the circuit. Right-click on the circuit and select Implement in the drop-down box. Implemented circuits are in service as soon as the implementation process completes. The user needs to be patient while the circuit implementation is processed by the iNMS software. There is a lot of behind-the-scenes interaction between the network elements, iNMS, and the database. The communications is all based on SNMP commands. The final step is to commission the circuit. Right-click for a drop-down box and select Commission. We are almost done now, except for occasional alarm cleanup. That comes next. Our circuit came up with an alarm. This is not unusual as the circuit ends come up sequentially. One end may often be ready before the other one is up and ready. The alarm needs to be acknowledged and cleared. Right-click on the alarm and select correlated alarm information to start the process. Move the cursor to the upper left open cell. Click to highlight and select all the cells. Right-click for a drop-down box. In the drop-down box, select Acknowledge Alarm. Then repeat the process to clear the alarms. After selecting Clear Alarm, you can close the window. Go back to the circuit window. The X to close the alarm window is in the upper right corner. Refresh the screen to see that the alarm has cleared. We now have an MPLS TP T1 SATOP pseudowire circuit over 10G transport.